Good morning. My name is Madhuri Thorat from ASSMS IOIT College from IT department. Today I am going to explain you Pushdown Automata. Pushdown Automata is a way to implement a CFG in the same way we design a DFA for a regular grammar. A DFA can remember a finite automata of information, but a PDA can remember an infinite amount of information. A PDA is more powerful than finite automata. Any language which can be acceptable by finite automata can also be accepted by PDA. But PDA also accepts a class of language which even cannot be accepted by finite automata. Thus, PDA is much more powerful and superior in finite automata. These are the basic components of PDA, that it is a input tape, finite control and the stack. Input tape is divided in many cells or symbols. The input head is read only and may only move from left to right, one symbol at a time. Finite control. The finite control has some pointers which point the current symbols which is to be read. And this is the stack. The stack is a structure in which we can push or remove the atoms from one end only. It has an infinite size. In PDA, the stack is used to store the atom temporarily. Okay, this is the formal definition of PDA. The tuple of PDA is defined as the m equal to q summation tau q0 z f and delta. Q means the finite set of states, summation is the input sets, tau means the stack symbols which can be push or pop from the stack, q0 is the initial state, and the z a start symbol which is in the tau. F is a set of final states, and the del is the mapping functions which is used for moving from current state to the next states. Okay, this is the explanation of or definition of instantaneous description. It is defined in the triple format, that is the q, w and alpha. Q describe the current states, w means the remaining inputs, and the alpha means the stack content top at the left. Okay, now we see the one example of PDA. Problem statement is the design a PDA for accepting a language a raised to n, b raised to 2n such that n is greater than or equal to 1. In this language, n number of a's should be followed by 2n number of b's. Hence, we will apply a very simple logic, and that is, if we read single a, we will push 2 a's onto the stack. Okay, we see the solutions. Okay, as soon as we read b, then for every single b only one a should get popped from the stack. Okay, first of all we see the id, that is the instantaneous description. It is structured in the del. Okay, that is the transition function. First of all we see del q0. q0 means the current state, a means the input symbol, z means the top of the stack, equal to q0 means the next state, and when the input a is arises, then stack will push the symbols into the stack. Then second transition is for the multiple a's. When multiple a's are occur, that time we push a multiple a's into the stack. Now when we read b, we will change the state from q0 to q1. Okay, state q0 to q1. The start popping corresponding a's, hence pop a. Thus this process is popping b will be repeated unless all the symbols are read. Note that popping action occur in state q1 only. Okay, in state q1 only. After reading all b's, all the corresponding a's should get popped, hence the stack will be the empty. Then when we read epsilon as a input symbols from the stack, there should be nothing in the stack. Okay, hence the move will be del q1 epsilon z equal to q2 epsilon. That is, the q2 is the final state which is accepted by PDA. Then we define a tuple, that is the m equal to q summation tau q0 z f and del. Q means the set of input states. In this transition we see that q0, q1 and q2 are the input states. Okay. Summation means the input alphabets A and B. Okay. Next one is the tau. Tau is the symbols which is push or pop onto the stack, that is the A and Z. Del, here is the del is defined. q0 is the initial state, Z means the top of the symbol, top of the stack, and the q2 is the final states. Okay. This is the diagram of PDA. It can be drawn with the help of the transitions. Okay, these are the transitions, and we draw a diagram as q0 is the initial states. When the A input is occur, that time all A's are pushed onto the stack. When the B is occur, that time the one by one A will be the pop from the stack. At the end, when the epsilon remains on the stack, that time QF means the final state we use as a Q2 means the final state which accept the all the inputs. Okay, thank you.